Hello and welcome to RBytes. Today, we will discuss the steps to construct this beautiful bump chart using R programming. Our goal is to break down the plot construction process into bite-sized pieces for easier comprehension. Today, we will consume 7 bytes of coding that cover the construction of our data frame, the building of a basic bump chart, and turning the basic plot into a masterpiece. In order to construct the bump chart, you will need to install the dplyr and ggplot2 packages, if you have not done so already. Otherwise, you can call them using the library function. Time for our first byte. In this section, we will discuss where to get the data and how to get it in the proper form to begin our plotting. Our data source today comes from the Social Security Administration website. The URL is included along with a screenshot of data showing the top 5 female baby names for the years 2015 to 2022. Unfortunately, this data is not in a very good format for our purposes, so we are going to change it into a data frame that maps the years, baby names, and popularity rankings into their own columns. Pictured on the left is the code used to accomplish our task. On the right are snippets of code that you might not be familiar with. In our code, we have organized our data into a list of vectors using the list function, which is then passed into the structure function. The structure function gives our data objects specific attributes. The names attribute defines the names of our object. The class attribute turns our output into a data frame. And the row.names attribute assigns each row of our data frame an integer value that spans from 1 to 40, or in other words, the number of rows in our data frame. Now, as long as everything worked, fingers crossed, we have our data frame of female baby names data. Now on to byte number 2. In this section, we will go over how to quickly make a basic bump chart. First, let me describe the layout of your screen. At the top is our R code used to produce the plot displayed below. On the right are some new code snippets. As seen in the code, we are using the ggplot function to construct our plot. The data frame we created previously is the data input for this chart. The AES function is used to define the aesthetics of the plot. Within it, we define our X values as year and our Y values as a popularity ranking. The group argument that follows is critical because it groups the common name values together rather than evaluating them all separately. The lines and points pictured in the chart come from our gmLine and gmPoint functions, which contain a color argument that tells R to color our line and point elements based on the baby name they correspond to. This function of scalar reverse is important because it flips our y-axis so that our rankings go from top to bottom rather than bottom to top. Just a quick warning is make sure that your y values are numeric, or else you will get an error and it won't work. Moving on to byte number 3, we are now going to begin our process of beautifying the plot by increasing the width of the lines and the size of the points. To begin, I have highlighted the new elements of our code that have been added to achieve our section goals. We now have an alpha, line width, and size argument. The alpha argument controls the transparency of our plot lines. The default is 1, and its values range from 0 to 1. I have set the alpha values to 0.5 to create a highlight effect on our lines, just for funsies. I next use the line width and size arguments to increase the size of my plot lines so that they stand out more. Moving on to byte number 4, we are getting there. This is one of my favorite sections because we get to play with some colors. In case this is helpful to any of you, there is a wonderful free access website called Coolors that lets you randomly generate color palettes at the click of a button. This is a fast and easy way to find colors that go well together. The number and letter combinations displayed on the color bars are called hex codes, and you can easily copy and paste them into your code. You can see at the top of my code that I've added a variable called color palette, where I have stored my colors as hex codes. I can then call these colors into my chart by using the scale color manual function. One quick note, The legend on the plot organizes my baby names into alphabetical order, and this is the order that R uses to assign my color values to my name values. Moving on to bite number 5. Now that we have our lines arranged in beautiful colors, let's change the backgrounds and grid lines to help them pop. First things first, let's quickly go over some important plot elements. The theme function in R lets you edit the theme of your plot by hand. In my first block, I am changing the plot and panel background using the element rect function. In the second and third blocks, I am using the element line function to change the color and width on my grid lines. Note that these are grid lines that correspond. There are grid lines that correspond with the X and Y axes separately. Now that we understand the elements, let's apply them to our plot. You can see that I changed my plot background to a light gray color along with my X-axis grid lines. I removed completely the grid lines associated with the Y-axis using the element blank function. To help the color of the lines pop out, I changed the panel background to be white. I think it looks much better, at least in my opinion. We made it to bite number 6, and we are almost there. In this section, we will address the title and subtitle of our plot, along with some needed adjustments to our axes labels. Once again, let's gain a basic understanding of the functions that correspond with our titles and labels before we apply them to our bump chart. Within the theme function, we are using the element text function to make changes to the fonts of our title, subtitle, axes titles, and text values. Notice that you can change the font size, color, and face. However, let's not forget that we must define what we want our titles, subtitles, labels, etc. to be, using the labs function pictured in the bottom section of our code. Now we are applying what we learned to our plot. Using the labs function, I gave our plot a fabulous name along with a helpful subtitle. This is a fun section to play around with because you can customize your plot to look any way that you want. To give you a better view of what we have accomplished, here is our plot of all of the changes that we have applied thus far. It looks pretty good, but there is still one more thing to do. Now we are on to our last bite. We will get rid of our baby names legend and move the baby names to be labels on the left and right side of our plot. To finish off, we will adjust our plot margins. Pictured on the left is the code that we have done so far, plus the code needed for our next steps. We have come a long way. Near the bottom of our code, we can see a highlighted portion called legend position. By setting this equal to none, we are specifying that we don't want a legend to be positioned anywhere. The plot margin highlighted portion below it is where we can specify the size of our margins. The first argument in this vector corresponds with the top margin. The second argument is the right margin, the third is the bottom, and the last is the left margin. I can specify the units that I want my margin values to be by using the unit function within plot margin. The highlighted geom text values above are what we will use to add our baby names to the left and right sides of our plot. We use the geom text function when we want to add text to our plot. We have two geom text functions in this case because we want to add the baby names to the left and right sides of the plot. When looking inside the geom text function, we see that we have a filter function. By specifying the values that have the year equal to 2015, we are only keeping the data values that correspond with the first point for each line on the plot. On the other hand, in the second geom text function, we are specifying that we only want the data values that correspond with the last point for each line on the plot. The label function in geom text is where we specify that we want the baby names to be the text that is displayed. The X argument is a little more difficult to understand, but hopefully the diagram on the right helps a little bit. The X value is telling us where the text should be positioned on the X-axis. By setting the X equal to 0.65, I am saying that I want my text values to be centered just a little bit before my first X-axis label. One last argument that I would like to cover is the color. By specifying that the color is equal to baby name, I am saying that I want the color of my text values to match the color values associated with my baby names. By doing a quick comparison between our current plot and the one from the previous step, we can see how adding the name labels to the axes made it easier to interpret the data within the plot, specifically what color is associated with what name. Now is the time for the final unveiling. Drum roll, please. That is a lot of code, but I think, as you will see next, that it has paid off. Here is a comparison between our basic bump chart and our end product. I don't know about you, but I would call that a masterpiece. Thank you for watching.